Throughout mankind's history, we have had a fascination with shapeshifters, whether it was the werewolves we commonly see in ancient mythology, the vampires that we see in popular media, or even the reptilians that appear so often in conspiracy theories. Now, what if I told you that shapeshifters do exist, not as mythical creatures, but as particles? Enter the neutrino, a tiny, tiny particle that is created in nuclear reactions, such as the fusion of hydrogen into helium in the sun's core and atomic decay. Neutrinos are like ghost particles. Most of the time they can pass through matter without leaving a trace. Every day it is estimated that trillions upon trillions of neutrinos pass through your body and through Earth. There are 3 different types, or flavors, of neutrino, each named after one of the 3 lepton particles. Now what are leptons? Leptons are negatively charged particles. The 3 leptons are the electron, the muon, and tau. You see, the weird thing about neutrinos is that each neutrino is actually a mixture of the 3 different flavor states. Kinda like this tub of Neapolitan ice cream I have right here. You see, this ice cream is a mixture of strawberry, vanilla, and chocolate flavors, just like how the neutrino is a mixture of electron, muon, and tau flavors. Kinda crazy, huh? But wait, it actually gets crazier than that. You see, along with being a mixture of 3 different flavor states, each neutrino is also a mixture of 3 different mass states. These mass states are simply numbered as 1, 2, and 3. Each mass state is also a mixture of the 3 different flavor states, and simultaneously, each flavor state is a mixture of the 3 different mass states. Now, there is a thing called the uncertainty principle, which states that the more and more we learn about one variable, the less and less we will know about the other. In the case of neutrinos, if we know its flavor state, we can't know its mass state, and if we know its mass state, we can't know its flavor state. So you could think of the tub of ice cream as a certain mass type neutrino with 3 different flavors, or as a certain flavor of neutrino with 3 different mass states. Now, you may be asking yourself, how can the flavor and mass states be mixtures of each other at the same time? Well, this property of neutrinos can happen due to the magic of quantum superposition. You see, in quantum superposition, different states can actually combine to form a new state, which is the sum of all the states added. But wait, it doesn't stop there. In 1998, they found that the ratio of muon to electron neutrinos in the atmosphere consistently shifted from the predicted ratio of 2 to 1. How did this happen? Well, since the neutrinos are a mixture of 3 different mass states, this means that different parts of the particle will travel at different velocities. Each mass state is a superposition of the flavors, which means that the ratio of flavor mixture will change, thus changing the overall flavor of the neutrino. Since the mixtures of flavor and mass can be very random at times, the probability of a neutrino changing flavor when it's detected may not always be certain. Thus, we must use an equation to determine the probability of a neutrino changing flavor. So let's do some math. I know this equation may look intimidating, but it really isn't once we actually break it down. You see, to obtain the probability, we must first multiply the mixing angle, which is the degree of separation between similar mass states represented by theta, by 2. Then we must multiply the mass of the particle by the distance traveled before dividing it by its total energy, multiplied by a coefficient of 4 and represented by E. However, doing just that will result in a number that is too high to be calculated as a percentage. That is why we must multiply both functions by sine squared before we multiply them together in order to obtain a tangible percentage. So now we know exactly how these tiny little neutrino particles change shape as they move through space. It's kind of cool to have an example of shapeshifting right in our own physical universe. Who knows what kind of cool physical phenomena we might find next?